Okay, so there's considerable trouble with this problem, so I thought I'd explain it. Here's the problem. What volume of a 0.1 molar HCl solution should be added to 500 ml of a 0.5 molar formic acid solution in order to prepare an acid solution of pH 1.5, and you're given Ka. So now you take what's actually happening here. You're taking a strong acid, adding it to a weak acid, okay, and then trying to figure out what the pH is. Obviously what's going to happen here is the common ion effect. You can obviously ignore the self-ionization of water because these are pretty significant concentrations. So H plus from water will not matter. Now, what's your initial moles of formic acid? It's 0.5 times 500. I've left this as ml, so I get 250 millimoles. Let's assume V is the volume of HCl needed in milliliters to get this pH of 1.5. This means that our because the pH is 1.5, it means that the initial moles of H plus that you have from HCl before equilibrium occurs is 0.1 V, and that's in millimoles because V is in milliliters. The equilibrium concentration of H plus is going to be 10 to the minus 1.5 because at equilibrium the pH is 1.5 and pH is defined as minus log to the base 10 of concentration of H plus ions. Here's the table. Here's the dissociation of formic acid. This is the initial number of moles, that's 250 millimoles, which we computed here. Initial number of moles of H plus is all that came from HCl, which we computed here, 0.1 V. And then there's COOH minus, which is 0 because there's been no dissociation of formic acid. Once equilibrium is established, we assume that X moles of formic acid dissociate, so you get 250 minus X, that's left when equilibrium is formed. Number of H plus ions or millimoles of H plus goes from 0.1 V plus X, X being the millimoles of formic acid that have dissociated. And similarly you will have X moles of COOH minus that get formed. What's the final concentrations? We need to divide by volume. Note that I've divided by the volume in milliliters because this is millimoles. So I'll still get moles per liter by doing this. And these are the various concentrations at equilibrium. Now by the definition of Ka, which is given over here, is equal to this number, X by 500 plus V, times this number, which is 0.1 V plus X by 500 plus V, divided by this number, which is 250 minus X by 500 plus V. But we already know that this H plus ions, concentration of H plus ions, is 10 to the minus 1.5. So that helps us simplify things. And if we do this, here's what we get. We get Ka, which is 2 into 10 to the minus 4 equals 10 raised to minus 1.5 times X by 500 plus V, divided by 250 minus X divided by 500 plus V. You get some cancellations here, and what you get is a pretty simple equation in X that you can then solve for. Now also remember, so you can get X this way. Remember that concentration of H plus ions at equilibrium is 0.1 V plus X by 500 plus V, which we just calculated, and we said that's equal to this number, 10 to the minus 1.5. If you know X, you can calculate V quite easily from this.